Hello and welcome to the Tentative Tutor channel. Here's an interesting question. For what integers n does n divide 2 to the n plus 1? I'll solve this problem in 3, 2, 1. Let's look at some examples. For n equal to 3, does 3 divide 2 cubed plus 1? Let's give it a try. 2 cubed plus 1 is 9, and in fact 3 divides 9. So that works out. What about any other numbers? Are there any other values of n that might work? It turns out there's an interesting pattern. Any power of 3 will work. Let's list some powers of 3. 3 to the first is 3. 3 squared is 9. 3 cubed is 27. And let's test them out. 2 cubed plus 1 is 9. And 3 divides 9. 2 to the 9th plus 1 is 513, and in fact, you can check 9 divides 513. Does 27 divide 2 to the 27 plus 1? Can you work that out? It turns out any power of 3 will work. That is, 3 squared will divide 2 to the 3 squared plus 1, 3 cubed will divide 2 to the 3 cubed plus 1, and so on. How can we prove this? We can do this by a technique called mathematical induction. We know it's true for n equal to 1. 3 to the first, which is 3, divides 2 to the 3 to the first plus 1, which is 9. This is called the base case. Now we'll suppose it's true for n equal to k for some integer k greater than or equal to 1. That is, we're assuming that 3 to the k divides 2 to the 3 to the k plus 1. This is called the inductive hypothesis. We have to show the statement holds for n equal to k plus 1, and we call this the inductive step. We have to show that 3 to the k plus 1 divides 2 to the 3 to the k plus 1 plus 1. How can we do this? Well, write the right-hand side as the sum of two cubes and then factor it using this identity. We'll let x be 2 to the 3 to the k, and y will be 1. And this is what we get. So we only need show that 3 to the k plus 1 divides this right-hand expression. But by the inductive hypothesis, we're assuming that 3 to the k divides 2 to the 3 to the k plus 1, which is the left-hand factor. So we need only pick up an extra factor of 3 for the right-hand side. That is, we only have to show that 3 divides that right-hand expression. However, from our inductive hypothesis, 2 to the 3 to the k must be congruent to minus 1 mod 3 to the k. It leaves a remainder of minus 1 on division by 3 to the k. If we then substitute in minus 1 for 2 to the 3 to the k, this is what we get. And if you do the arithmetic, you get 1 plus 1 plus 1, which is 3 mod 3 to the k. If it leaves a remainder of 3 on dividing by a power of 3, it's got to be divisible by 3. So in fact, 3 must divide this expression. We get our extra factor of 3, and we've proven our result. Now here's our bonus problem. For what integers n does n divide 2 to the n minus 1? Can you do it? Leave your answer in the comments, and thanks for watching.